Hi, and welcome to my JavaScript tutorial in which I will teach you how to code in JavaScript by building your very own basic game of Tetris. I always find that learning is easier by doing, so if you're the same, this tutorial is definitely for you. And hey, you'll have a pretty neat JavaScript game by the end of it. This tutorial is for super beginners, and we will be going through the fundamentals of JavaScript as well as some inbuilt functions that are going to help us build our Tetris game. If you have never touched code before, this is a pretty good place to start. We will be going through some CSS and HTML as well, but just the basics. As you know, this is a JavaScript tutorial. If you do have some prior knowledge of HTML and CSS, please do not skip the first few lessons. We need them in order to set up our game. Feel free to watch them on double speed if you prefer. Tetris is a simple grid-based game in which you, as a user, have to navigate 5 shapes, or Tetrominos, down to the bottom of your grid. The aim of the game is to get the highest score by filling up rows on your grid in order for them to disappear and for you to gain points. You, as the user, can rotate your shapes, and you also have insider knowledge by knowing which shape is coming up next thanks to a grid to the side of your grid. In this game, we are not going to have levels. We are simply going to do a basic version of the game. Basic functionality and basic styling. This is so you can take it and make it fully your own. I would love to see all your finished projects, how you have made them your own in terms of styling or leveling up, so please do share them with me. Please do get in touch if you get stuck at any point in this tutorial. I am always more than happy to help. Again, please do use my social links below. So yeah, let's get going. In this walkthrough, I'm going to show you my preferred code editor, as well as the bonus of how to set it up so that it works for you like a sort of spell checker, if you will. It will check your code for mistakes and prompt you to change things in order for it to work. I am also going to show you what a command tool is and how to use it to access files and folders on your computer, as well as speak to them and download things from it. Okay, so let's get going. First off, start by downloading a code editor. I'm going to use Atom. If you go to atom.io and download the program, that will be the tool you use to write code in your project. Now copy it into your applications folder and add it to your dock. Once that has been downloaded, you'll use the command line system to create a folder to store your project. If you have a Mac, simply search for Terminal in your Launchpad. If you're on a PC, you need to search for your command prompt tool. Now, open up your terminal, and using ls, you can list all the directories. Now, using cd to enter a directory, we navigate to the desktop. It is on the desktop that we're going to create our project called Basic Tetris. So, using a command called muckdir, we're going to make a directory called Basic Tetris. Okay, great. We now have a folder to store all our code files in it. To go into this folder, again, we use cd. Let's use the command cd to go into this project. If you ever want to get out of this project, we use cd with 2 dots like this. But we don't, so let's go back into it. Once in this folder, we need to create files to go in it. We do so using a command called touch. Touch will create files. We need to create an HTML file, CSS file for our styling, and a JavaScript file to hold our JavaScript. I'm going to choose to call them index.html, style CSS, and app.js. Okay, perfect. Now using atom dot, as we are using the Atom code editor, we will prompt the project to open in our Atom code editor. And there we go. We are now set up to start writing some code. Now, I'm going to show you some useful settings on Atom that will make your life a whole lot simpler. Atom allows us to add packages. There are literally loads and loads of packages out there that you can pick and choose, so I'm simply going to go through ones that I find useful for my projects. Open Atom and click on the Atom menu, then Install Shell Commands. Now, click on the drop-down and Preferences. In Preferences, in the Editor panel, make the following changes. Show Indent Guide, check. Show Invisibles, check. And Tab Type Soft. Now, let's go over to our terminal and type the following code. What we are essentially doing here is downloading packages for Atom to use via the command line tool. Once these have all downloaded, let's quit Atom. Now let's reopen it to see the packages that we installed and go through them all a little bit more, one by one. In the navigation, find Packages and click on the drop-down. You will see here all the packages we installed using the command line and APM command. We have auto-indent. Auto-indent will auto-indent your code correctly in your files. This is good for code readability and considered best practice. Atom.js is a package that adds support for ES5, ES6, ES7, ES8, Node.js, and more. This means that it will let us use features of all of them in your code editor. For example, an arrow function, which you will definitely come across, is something that is a feature of JavaScript ES6 and above. We are also going to have something that will spell check our code and check our JavaScript code in a way that will notify us if something isn't working correctly. For this, we will use linter.js standard. Okay, great. You are now all set up to start writing JavaScript projects. Let's carry on. Hi, and welcome back. In this project, we're going to be using an HTML file and a JavaScript file in order to make our project. HTML is a hypertext markup language used as the basis of a web page. HTML consists of tags surrounded in angular brackets, like this. The HTML tag can be used to define headings, titles, images, links, buttons. There's a whole load of tags available to your disposal. In this lesson, we're going to be focusing on the HTML file and how to link it to our other files, such as our JavaScript file and CSS style sheet. The first thing we're going to do is make sure to check our files are named accordingly. The most important thing is the ending or file extension. We need to make sure that we use .js to let our code editor know that we are going to be writing JavaScript code in this file and to treat it like a JavaScript file. We also need to do this for the style sheet or CSS file. CSS stands for Cascading Style Sheet. We will cover that in the next lesson. Now we need to link the JavaScript file to the HTML file. We will do so by putting a script tag in between the head tag, then using a DOM event listener in our JavaScript to make sure this tag is read after all the code in this HTML file has been read. An alternative way to do this is by putting the script tag at the end of the document in the footer, but this is the way we're doing it for the sake of the tutorial. It is important to note that in this script tag, the source, or src, as you can see here, the text in between the quotation marks needs to be the relative path of where the JavaScript file is. As the file is in the root of our folder, we simply write app.js. If your app.js file happens to be in a folder, you will need to change this relative path in the script tag. So to recap, if the file is in the same location as your HTML file, we write this, and if it's in a subfolder, to your index.html file, we write this, replacing the green folder with whatever you have named your folder. Please do remember to keep your index.html file at the root of your folder. If you do not, our browser will not be able to read this project. Well, not without loads of configuration anyway. I am actually going to flip over to our JavaScript file and add the DOM event listener now too. We must make sure all our JavaScript in the future is written in between these two parentheses. We need to make sure this is done so that it's picked up by the script tag we wrote earlier in our HTML file. Okay, so let's go ahead and add that event listener to our JavaScript file like so. Again, the DOM content loaded event fires when the initial HTML document has been completely loaded and passed. This is without waiting for the style sheets, images, and subframes to finish loading. The target of our event is the document referring to the HTML document. Okay, now back to our HTML file. So now we're going to link our style sheet in a very similar way, but using a link tag instead. Add the following tag in between your head tag. Again, make sure the relative path of the file is correct. We do not need to add anything into our CSS file for this to be picked up. Now that we have linked our two other files in our HTML file, let's start by adding some code to our body. Now, we first need to plan exactly what we want our Tetris game to look like in terms of shape. As we're going to be making a grid-based game, I would suggest drawing this out first, or using something like Google Sheets like me to get an idea of what we have to get on with and tackle. I'm going to flip over to Google Sheets now. I have actually pre-drawn this to give you an idea of what to be aiming for. You can make your own grid as big or as little as you want, it's up to you. So you can see here, I want to make my grid 20 squares tall and 10 squares in height. So how would we make these 200 squares? We need to make them in our HTML file and then add styling to them with our style sheet or CSS file. So let's do it. Let's code out 200 divs in our HTML file. There are other ways of doing this from the JavaScript file that involve creating an element 200 times using a for loop. But as we are just starting out, I think it's important to focus on a more visual way of learning so we can see what's happening. Now, let's put these 200 divs in a div of its own that we are going to give a class name of grid to. We are doing this so we can contain the 200 divs in a div of its own that we're going to start in our CSS later. Now, we are going to want to display the score. Let's do that in an h3 tag like this, with a span inside of it, like this. h1, h2, h3 tags are all header tags. h1 being your main one, and going down in size all the way till you hit h8. Okay, moving on. Let's give this span an ID of score, so we know exactly which span tag to display the future score in, just in case we use another span tag in our project. As opposed to class names, IDs are unique and can only be used once. I am also going to hard code a 0 here for now. Finally, I'm going to add a button using the button tag. As I want this button to start the game, I'm going to give it a very clear ID of start button. Okay, let's save these files. We are going to right click just here so we can open this file in our browser. Amazing! Though you won't see the 200 divs as they have no styling applied yet, you can see them if you inspect the page. If you do not know how to inspect the page, you can simply do so by pressing down the control button on your keyboard and left clicking the browser like this. Check out this nifty animation I did here. It is also where you view the console log. We will be using the console log later. It's a tool that allows us to see what's going on under the hood when writing JavaScript and is super useful. Okay, great. Thanks for this lesson. Let's move on after just a few questions. In this lesson, we're going to be covering CSS, or cascading style sheets. CSS is a simple mechanism that allows you to add styles, so fonts and colors, to your web documents. Becoming a pro at this takes a lot of practice. We are simply going to be doing the basics in order for us to carry on learning JavaScript, as this is a JavaScript tutorial. This will include styling to make our grid look like a grid, add colors to our Tetrominos, and touching a little bit on Flexbox. Once you have finished this tutorial, please do go back and add as much styling as you want. Feel free to share it with me. I would love to see your finished games. Okay, let's start off by giving some styling to our grid. The first thing we're going to do is navigate to our style CSS file. Now, let's pick out the div with a class name of grid. We tell our style sheet we are looking for a class by using this dot before the class name. So, as a recap, we are picking out the div with a class name of grid that has 200 divs inside of it. Let's say we want our squares to be 20 by 20 pixels. At a 10 by 20 grid, that would mean we need to make the width of our grid 200 pixels and the height 400 pixels. I'm going to make it yellow so we can see it in our browser. Now, we are also going to style the divs in the grid. We do so like this. We put the div element after the element with a class name of grid. By doing this, we are saying that we want to style only the divs in that element like this. So essentially, all other divs we use in the future in our project will be unaffected by this styling. Okay, so inside the parentheses, we're going to assign the height and the width. Let's also make them red, just so we can see them in our browser. Okay, let's save that file and refresh our browser. You will see the red squares show up as a stack over each other. This is the case by default. Divs do this. They stack over each other, unlike H3 tags, which appear in line. This is where Flexbox comes in. We need to use Flexbox to make sure the red squares appear stacked in a line, and then stack over each other as soon as they don't fit in the grid div width parameter. Let's add display flex. And save, and refresh the browser. And there we have it. We now have a grid we can work with and start adding some JavaScript code and game functionality to. Let's move on just after a few questions. In this video, I want to take a break just to explain what variables are and how we use them in JavaScript. So in JavaScript, you can store values in something called variables. They are legal identifiers. Quite simply, it is this. So the variable x here equals 1. It is important to note that when you declare a variable, its name must be unique. You can assign numeric value to your variable, like the number 1, or a string value, such as 1 in quote marks, an array, such as 1 and 2 in an array, a boolean, such as true or false, or you can just leave it undefined for later use like this. Now, by definition, variables mean anything that can vary. So let's see this in action. Let's get x and assign it to the value 23. Note, we do not use var again as we have defined x above. Let's go ahead and console log that. And you will see x has now changed value. Now, let's talk about scope. When defining variables, it is important to know that they have scope. Variables have two types of scope, global scope or function scope, meaning they can only be accessed inside our function. Let's have a look at this in action. Here is a function I have written to alert me with a name. Let's put the var name here, outside the function. Okay, that works. This is because it's a globally scoped variable. Now I'm going to move it here, inside the function. This also worked as the variable is declared inside the function. However, what happens if I now want to show the alert outside of this function? It will not work, as the variable is not being picked up as it's inside this function's scope. Essentially, it's out of our reach now. Okay, got it? Now, let's talk a little bit more about const and let and how they differ from var. So, when ES6 came in, it introduced two new ways to create variables, let and const. So what's the difference? Let's talk a little bit about the difference between let and var first. Let allows you to declare variables that are limited to a scope of a block statement, unlike var. What does this mean? Well, let's have a look at an example. Okay, so I'm going to declare variable x here as 1. Now, I'm going to write a function here called findX. Inside, I'm going to declare variable x again as 2. Now, if I want an alert telling me what 2 is inside this function, I will get 2. However, what will I get if I want to move the alert outside of this function? I will get 2, as variable is global and we declared it after the first declaration. Now let's do the same but using let. So all I'm doing is writing the same thing but replacing var with let. You will now see that we are getting a 1 as the other let inside the findX function is out of our scope. Now, finally, const. Const works in the same way let does in that you cannot access it if it is inside a function. However, it is also constant, as const would allude to. Once you have defined it, you cannot change it later on. This is pretty useful when working with big projects and declaring what you do not want to be changed. Let's have a look at this in our code editor. Okay, so there we have it. Let's recap. Var, a function scoped or globally scoped variable. Let, a block scoped variable. And const, a block scoped variable that cannot be reassigned. Okay, now we have a grasp on variables, let's go back to our game of Tetris. In this lesson, we're going to start adding functionality to our project by adding some JavaScript code. We will especially be focusing on JavaScript arrays and how we will be using them in order to make our game. An array is a special variable which can hold more than one value at one time. If you have a list of items, so a list of Tetromino names for example, storing the Tetrominos as single constants would look like this. However, what if you want to loop through these Tetrominos and find a specific one? And what if you had not 5 but 200 of them? The solution is an array. An array can hold many values under a single name, and you can access the value by referring to an index number. We will be using the index number a lot in this course. JavaScript arrays are 0 indexed, meaning that the first element of the array is at index 0, and the last element is at the index equal to the value of the array's length property, -1. This is important for our game, but also for JavaScript array knowledge in general. The first thing we're going to do is tell our JavaScript the width of our grid in squares using const. So let's flip over to our JavaScript file now. As the value will not change, we are going to use a const. So as a reminder, the const keyword denotes a non-mutable view of mutable data. Next, we are going to use something called a query selector to look through our HTML document and find the element with a class name of grid. Document query selector is an inbuilt JavaScript method. You will see here we are using dot again as we are looking for a class name. Once we find it, assign it to the constant we have decided to call grid. Now, our JavaScript knows that every time we type grid and do something to grid, we want it to affect the element with the class name of grid in our HTML file. Now, we also want our JavaScript to talk to all the squares in our grid using the query selector again, but this time using document query selector all, as we want to collect all the divs inside the element with the class name of grid. We do this. Now, what we are going to do involves an inbuilt JavaScript method called arrayFrom. We are going to use it to, in layman terms, collect all the divs in our grid, all 200 of them, and turn them into an array we can work with. Now, each div will have a specific index number. Let's pass these collected divs through arrayFrom to make them an array and assign it to letSquares. Let's get our console up here so we can see what our console log tells us. Now, hit refresh on your browser. Okay, great. You will now see that these squares is an array of 200 divs with index numbers from 0 to 199. The reason it says 0 to 199 instead of 1 to 200 is that the index count always starts at 0. What does this mean for us and our game? Well, we just need to learn how to count a little differently. Let's have a look at our grid and the squares inside numbered by their indexes. This is something that I made in Google Sheets earlier to make it easier for us to understand. You will see that if we want to be in the 5th square, so this would be the 5th square here, we would need to tell our JavaScript we want to be in the index 4 of our squares array. Why is this an array again? Because we collected all the divs and passed them through arrayFrom. Okay, let's move on. The last thing I'm going to do for this section is get a few more things from our HTML document. We are using a hash here to indicate we are looking for an ID. So if we look at our HTML page, as a reminder, we gave the span tag an ID of score and this button an ID of start button. Let's go ahead and pick them out again with our query selector. There is also a get element by ID. Feel free to use that as well. I'm going to use this query selector. Okay, great. That's it for this lesson. Let's recap with just a few questions. In this video, we're going to take a quick break to go over exactly what a function is and why we use them. Functions are one of the main building blocks of JavaScript, and in fact, most languages. In JavaScript, a function allows you to write a block of code, define it with a name, and execute it as many times as you like. It's all about recycling code with functions. In this video, I will be showing you how to write a super basic function that we will later be adapting to use in our own game of Tetris. Okay, so let's flip over to our code editor so that I can show you a super basic example of a function first. So the simplest example I'm going to show you is a function that sets off an alert. The first thing we're going to do is write function like this, followed by a word I've chosen to call my function. This word should really convey what is happening in my function. We do this to make our code more readable for colleagues, or simply if we're forgetful. I'm going to choose to call my function showAlert. I am using camel case for this. Camel case is the practice of writing more than one word, joined as one, but visually separated by making each word after the first start with a capital letter. It has no spaces or punctuation. I consider this the best practice for writing functions. Okay, so after naming our function, we write these two brackets. These two brackets are for passing down parameters into our function. As we don't have any just yet, I will leave this blank. Now we have to put our block of code that defines a function in parentheses. I'm going to make my function show an alert like this. You will see I'm writing the inbuilt method of alert and passing through a string. A string is defined as a word in these quote marks. Okay, great. Now let's test out what we have written. We can invoke a function like this. Amazing. So that's the basics. Now let's pass a parameter or two into our function. So the thing about parameters is that if you choose to pass one, it needs to be one, and this needs to be reflected in the code we write. If you try pass any more than one, the rest of these parameters will be ignored. Let's have a look at it now. So say I want to pass down a first name into my function. And somewhere else in my code, I have recycled this function and written this. Okay, let's uncomment that. But as soon as I pass down my last name, that part will be ignored. It is the same for if I ask for the last name in the function, but I do not pass it through. I will get undefined. We can also use argument objects in functions. If we declare them outside of the function, we do not need to pass them through to use them. For example, I'm going to write an array called name. Now, using my function, I'm going to access the first item in my array, so index 0, like this. Okay, great. We are now ready to carry on with our Tetris walkthrough. In this video, we're going to talk a little bit about arrow functions and how we're going to use them in order to draw our Tetrominos onto our grid. In this lesson, we're going to be doing more array work and be introducing something called an arrow function, as well as an inbuilt JavaScript method called forEach. Arrow functions were introduced in ES6 and allow us to write shorter function syntax. Here is the original way we would write what was, and the evolution to what we now know as the arrow function. If you have parameters, you can pass them through the brackets like this. This is what we're going to be doing and involving the forEach method. The forEach method calls a provided callback function once for each element in an array in ascending order. The callback is invoked with 3 arguments: the value of the element, the index of the element, and the array object being traversed. Or in layman terms, we're going to get an array with a bunch of values and apply logic to each one. Here, we can see an example of forEach working on an array I have called item array. Using this code, I'm also going to pick out each item of that array so I can apply logic to it. You can see here I've chosen to call it item. I can call it anything I want really. JavaScript will know what I mean. It will know it's an item in my array. Now, using an arrow function, I do this and add 2 to each item in my array. So that's the syntax. Let's see in action. The simplest example I can show you of this happening is when we choose to add something to each item in our array. Let's make an array of names, so an array with strings, as indicated by these 2 quote marks here, and separated by commas, and put them in square brackets. Now, it's super important to remember what is inbuilt and what isn't here. Names is our array that we made above. forEach is the inbuilt method that comes with some magic that will make our JavaScript do things without us writing any logic for it. Name here is something that we have chosen to call the items in our array. I could call this whatever I want: chair, dog. My JavaScript will know I mean an item in my names array. This arrow is the arrow function we referred to in our last video. So what we are saying here is that for each item or name in our names array, we want to print out individually that name and add the string is the best to it. Okay, let's check that out. Okay, and that has worked, great. Now, this is a super simple example of how to use forEach with an array. There are literally so many different ways to use this inbuilt method. I always think it's better to learn with a working example, so let's get going and use the forEach method and arrow function to draw our 5 Tetromino shapes onto the grid. Let's do this in the next lesson. Okay, and welcome back. This is a continuation from the last lesson where we learned about forEach and how we're going to use it in order to draw the Tetrominos onto our grid game. The first thing we're going to do is get out our Google Sheets again and draw out every single rotation of each shape. Note, the O Tetromino will stay the same during each rotation, and the Z Tetromino and L Tetromino will only have 2 versions of itself. Once we are happy with each of the shape's 4 rotations, it's time to draw them using our width constant. Remember, we set that as 10 in our JavaScript file. Let's get going and start with our L Tetromino. We will set it as const, as the shape and its 4 rotations will not change. We will make the L Tetromino an array with 4 arrays inside it. Each of the 4 arrays is one of its rotations. If you see here, what I'm doing is using my drawing to draw the shape onto the grid as if I was only allowed to use the grid indexes. So, drawing in the index with number 1 on our grid shape and index with the number 10 plus 1 on our grid shape, 10 being the width, and index number 21 and the index number 2, it will give us this shape right here. Okay, now let's draw the other 3 rotations. We can do them all starting from index 0, no need to draw them in their locations on my drawing. Let's do that now. Once we have done that, we need to do the other 4 shapes in the same way. Now, because I have done this before, I'm simply going to copy this into my project from my GitHub account. You are welcome to go and grab the Tetromino arrays as well, but I would stress that I do advise against it and only suggest it if you are stuck and getting some strange shapes or error messages. By trying to make all the shapes yourself, you will get a better understanding of what we are doing here and what we are trying to achieve. It would also defeat the purpose of the tutorial if you're trying to understand JavaScript a little bit better. I mean, this is the perfect arrays exercise. Okay, once we have our 4 shapes, let's put them in an array of their own. Let's put this as a const and call it the Tetrominos. Okay, great. We now have our Tetrominos, but we can't see them. That's because we need to add some styling to them to see them first. Let's decide that we're going to make them all one color for now, just to make it easier. We can change this later, so let's flip over to our style sheet and add the following. Okay, now let's decide where we want to start drawing our Tetrominos on the squares grid. Let's say the first square of our chosen Tetromino's first rotation array is going to start at the square with index 4. So let current position equal 4. Now let's pick a Tetromino and its first rotation. So let's go to our the Tetromino's array of arrays. By putting a 0 in square brackets like this, we are saying we want to access the first item on our array. Let's look at this slowly. Okay, so first, let's console log the Tetrominos, our array of arrays. You can see that here. We have an array of 5 things, or as indexed 0 to 4. These are our 5 Tetromino shapes. If you click on the first one, so index 0, you will see inside it has its own 4 things in it. These are the first Tetromino shape rotations we wrote earlier. Let's click on the first one, so again, index 0. This should look familiar. It is the first rotation in our Tetromino. Let's go ahead and now console log the Tetrominos 0, and again in brackets 0. And amazing, it's the same. We now assign this variable to current. Just so we are all clear, I have picked the Tetromino's first rotation. This is now my current shape. Okay, now let's draw this using forEach to see if that's true. Let's write a function called draw. And in that function, let's get our current array, or what we have assigned as current above. Now, for each item in that array, we want to add a class of Tetromino, which would color that item, which is technically a div inside the element with the class name of grid. So this is how forEach works. It applies logic to each item of an array. We use the arrow function here, as we saw above, to add the code inside the parentheses to each index of the current array. Just like we passed the 0 into the array above to access the first item, we are passing on a number to the squares array to color it blue. We access the CSS style sheet by using classList.add to add the style of Tetrominos to the squares in the Tetrominos it is in. In this occasion, we are passing through a for. This is because we set the current position as 4, plus each index of the currently chosen Tetromino array. Okay, so now let's invoke this draw function like this. Now save your file and quickly go back to your CSS file to get rid of the red background we gave all our divs at the beginning. We no longer need this. Hit save again. And let's refresh our browser. And great, there we go. You can now see a blue Tetromino shape. It is the Tetromino in its first rotation. Okay, now let's go back to our JavaScript and select one of the Tetrominos randomly. For this, we're going to be using 3 more inbuilt JavaScript methods. MathRandom, which will give us a random number from our array length. Length, which is an inbuilt method that will tell us exactly how long our array is. And MathFloor, which will round down to the nearest integer. So let's add a variable that we're going to call random. To randomly select a Tetromino from our the Tetrominos array, we use an inbuilt JavaScript method called MathRandom and multiply it by the length of our Tetrominos array, length being inbuilt as well. We then pass this through another inbuilt method called MathFloor. This will round down the number to its nearest full integer. Okay, so let's see if that has worked. We should get a new number each time we refresh the page. Refresh again, and great. Now we have that, let's go back to our current variable and replace the first 0 with random. Now, what is happening here is that instead of passing through a 0 and accessing the first item of our array each time, we are passing through a number from 0 to 4 randomly. This will give back the first, second, third, fourth, or fifth Tetromino in our the Tetrominos array. Once we have one of these 5 shapes, we want to access it again, but always picking its first rotation. Let's set this as let current rotation equal 0. Now, if we pass this through, we will always start at the first rotation of any random Tetromino chosen. I'm just going to change this here to more accurately reflect what is happening now, just to be as transparent as possible. Let's uninvoke the draw function here too by getting rid of this code. Okay, now the last thing we want to do is write a function to undraw the randomly chosen Tetromino and its current rotation. We do the same as we did to draw it. So once again, we name the function undraw. We use a forEach. So for each item or index in our current shapes array, we look at each of their current positions add the index of the shape and pass it through our squares array. Now the only difference here is that apart from adding the class, we are removing the class Tetromino from its current location in the grid. So it will visibly disappear from our grid. Okay, great. We now officially have all our Tetrominos and can draw each one on our grid. Please do, if you're not quite sure, pause here and just have a go at messing around some of the numbers, replace the current position, so on, just to see exactly what's happening. Refresh the browser loads to see if you're getting a random Tetromino. If not, go over this lesson again. I will provide the code below as well, so don't worry if you feel stuck. In the next lesson, we're going to be focusing on moving the Tetrominos around our grid. Hey, and welcome back. In this lesson, we're going to learn a little bit about timer IDs and an inbuilt method called setInterval. SetInterval allows us to invoke a function that we pass through it after X amount of time. In this example, the time is 1000 milliseconds, or in other words, 1 second. We are going to be using setInterval for this project because we want our Tetromino shape to auto-move down the grid every second, just like in the real game. As mentioned in the example, we do this by passing through a function that we will call moveDown into the setInterval, as well as the milliseconds we want to invoke this function at. We are going to assign this to timer ID. This is so we can stop the setInterval in the future. Now, let's write the moveDown function using the functions of undraw and draw we wrote in our previous lessons. So, we want to undraw the shape from its current position and add a whole width to the current position and draw it again in its new position. Let's check if that has worked. Okay, great. We can see that the shape is now auto-moving down our screen. Sadly, it's not stopping and going through the bottom of our grid. This is something that we need to solve. We are going to do this simply by flicking back to our HTML and adding 10 more divs to the bottom of our 200 divs, this time with a class name of taken. As these do not have a style in our style sheet, they will not show up visibly. We just know that they have that class. If I inspect the page, you will see them there. Next, we need to write a freeze function. In this function, we want to write an if statement. An if statement looks like this. We pass through a condition in brackets before an if. Whatever the condition between these brackets is, has to give us a Boolean response, so a true or a false. If the condition is true, we carry out the next steps of whatever is in between these two parentheses. So here we have an example. If the temperature is above 20 degrees, so this statement is true, we return it is hot. Now, we can also write an if-else statement. An if-else statement is the same as an if statement, however, if the condition is now false, we can also return a response. So in this example here, if the temperature is not over 20 degrees, we return it is cold. Now, we can also keep adding and adding with this else if, and go on forever, just like in this example here. So here, if the temperature is not above 20 degrees, so false, we bypass this if statement and check the else if. If the temperature is deeply equal to, indicated by these three equal signs, that is deeply equal to 18, then we return it is warm. And of course, if it is not, then this statement is also false, and we return it is cold. So let's go back to what we want to happen in our if statement. If sum, another inbuilt JavaScript method similar to how forEach works. However, instead of applying logic to each item in an array like forEach, with sum we are checking that the logic we write in the brackets is true for some of the items in our array. So basically, if we ever get one true back, we are good to go. So if some of the squares that make up the current Tetromino, if their index plus a whole width, so essentially we are checking the next space down from each square, contains a square with the class name of taken. So if this statement is true for at least one item in our current Tetromino array, we turn each of the Tetromino squares into a square that contains the class of taken. Got it? We then also immediately select a new Tetromino to be our current Tetromino. This will be familiar. Let's get a random Tetromino number. We then pass this through our the Tetrominos array and its first rotation. We then set this as our current Tetromino. Then we put it at the current position, so 4, and finally we draw this new randomly selected Tetromino. Okay, that is it. That is our freeze function. Let's add this freeze function into our move down function so that it gets invoked to check every second. Oops, I missed the capital M of math here. That is really important. Please don't forget to add this here. Okay, great. Now let's flip over to our browser and see if that has worked. Amazing. Let's move on to the next lesson. Okay, so we now have an array of squares, great, and we have wrapped these squares over each other to appear like a grid. Amazing. However, in reality, how does our computer know when we are at the very left-hand side of our grid? What stops our Tetromino from going from this position to this position when moving right? Technically, we are in an array, so this would be the next logical step. We need to write a set of rules to let our JavaScript know when any of our squares that make up our Tetromino are in a certain indexed square. We are going to do this using good old-fashioned maths. As we can see here, our grid has a width of 10 made up of an array of squares with indexes 0 to 199. I want to make sure that if the Tetromino is in the square with index 10, I don't want it to move left anymore. I want to stop it, as otherwise it will appear in the square with index number 11. So I need to write a rule that will stop our squares if they are in the square with index 10, 20, 30, and so on. Let's get started by defining what is a move left function. What we're going to be doing is visually moving the Tetromino left by drawing it and undrawing it in the squares. We start off by removing any trace of the shape in its current location before we start, so that we have a clean slate. Next, we define what is the left edge and if the shape is in it. This is where our math comes in. For this, we use the inbuilt method called sum again. As a recap, sum is a method that looks at each item in the array and checks if a statement is true for at least one of the items. If it is, the whole statement is therefore true. So, once again, let's use current. As a reminder, current is our current randomly selected Tetromino and its current rotation. We are checking that sum of the current Tetromino's item indexes, if divided by the width, leave exactly no remainder. So, again, if one of the Tetromino squares is in a square, let's say that has an index of 10, we also know that 10 divided by the width, so 10, gives us exactly 0 as a remainder. This means our statement is true and the shape is at the left-hand side of our grid. This is also true for index 20, 30, 40, and so on. Let's use this information and only allow our shape to move left, or -1 from its current position in the array, if the shape is not at the left edge, indicated by this exclamation, or bang, here. We also want our Tetromino to stop if there is another Tetromino already there that has been frozen. For this, we are going to have a taken class. We are not going to style this class, we just want to assign it to the spaces that have been taken and we can't go into. We will use an if statement for this. What we want to write is, if some of the squares in our Tetromino shape suddenly go into a space that contains a class of taken while travelling left, we want to push it back one space so it appears not to have moved. We want to do this for every index in our Tetromino shape. So use an arrow function to do that, like this, and pass through the current position and add every index as it gets passed through. Then we add 1 to the current position so that it moves back to its original space in the array. And finally, we draw the Tetromino. Okay, so that was a lot to take in. So before we start writing the move right, move down, and move up function, let's wire this all up to see if it works first before we move on. Keycodes are pretty cool. Every single key on your keyboard has an assigned code to it that we can access through our JavaScript. We are going to use this to make our Tetromino move left if you press keycode 37, right if you press keycode 39, and make some JavaScript magic happen if you press the button down, and so on. You can technically make your Tetromino move left if you press just about any key on your keyboard that you choose. There is actually a pretty cool site called Keycode.info that will give you the keycode as soon as you press it when you're on the site. We will also be looking at passing through events into functions so that we can use them. So let's get started by assigning keycodes to functions. Let's write a function called control and add a document event listener to listen for any time we press a key on our keyboard. Anytime you press a key on our keyboard, we're going to listen out for which one was clicked and invoke the control function. We are also going to pass through an E here for event. Now, with if statements, we're going to decide what happens when you press a key. If we press the key that deeply equals keycode 37, we want our Tetromino to invoke this function, move left. Let's see if this works as we wrote the function in the previous lesson. Now, arguably the coolest part about JavaScript is making stuff happen in your browser. Well, you'll be glad to know this is exactly what the event listener does. The event target method at event listener sets up a function that will be called whenever the specified event is delivered to the target. Common targets are elements, document, and window. In layman terms, if you attach an event listener to something like a div and click it in your browser, cool stuff will happen. You just have to attach it to the element you have chosen like this. You can see here that we are passing through two things. The type of event, so in this case key up, and a function. In this case, it's the function control we have just written. You can also do remove event listener to deactivate any listening happening. There are literally so many events you can use. Here are just a few off the top of my head. So once again, the event listener here listens out to any time we press a key on our keyboard using the key up event. If a key is pressed, we invoke the control function we have just written. We attach this event listener to our whole HTML document. Okay, let's refresh our browser. And great, it works. The Tetromino is even stopping when we hit the left-hand side, which is great. Now let's figure out what we're going to do for the rest of the keycodes. I have commented out the other functions for now, as we have not written them yet, but just so you know what we need to do. So if I press up, I want the shape to rotate. If I press keycode 39, I want the shape to go right. And if I press down, I want the shape to go down, but faster. This is something we already have, so we can pass it through here again. Let's do the move right function based on the same logic as the move left and leave the rotate function for the next lesson. So once again, we undraw the squares that make up our Tetromino from their current indexes. We define what it means when some of the squares that make up our current Tetromino are in certain indexes and call this a constant of is at right edge. What you can see is happening here is that if an index is divisible by the width and its remainder deeply equals the width minus 1, so in this case 9 or 18 or 27 and so on, this statement is true and we are at the right edge. So if we are not at the right edge, indicated by the bang here, we can freely move each square in the Tetromino plus 1 down the array. Then, if some of the squares that make up our Tetromino are suddenly in a square that contains the class taken, we have to push them back a space in our array, visually making them appear like they haven't moved at all. And finally, we redraw the Tetromino in its new position. Let's try this out. Okay, great. We can now move left to right without going off the grid and to the bottom without our Tetrominos going past the squares with the class of taken. Let's move on to our next lesson. In this lesson, we're going to be doing more array work and also looking a little bit into the increment operator. The increment operator is going to help us access the next item in our Tetrominos array. We are going to be doing this as we need to access all 4 of each of our Tetromino rotations on the click of a keycode. We are going to be doing this using the double plus, so plus plus, which works in a way that simply means we are adding +1 to the defined value before it. It is called an increment operator. In this example, you can see how it works. If y is 5 and we use the increment operator on it, the y will now have a value of 6. And you guessed it, there's also a decrement operator. Using the double minus will make the value of our y change from 5 to 4. Now, let's use this in our code. We are going to write a function to rotate the Tetromino. This is actually us just skipping to the next rotation in the current rotation array. As always, let's start by undrawing the shape. Next, we use the increment operator to move down to the next item in our array, so the layout of our next rotation we drew out for the current Tetromino. Using an if statement, we say that if the current rotation index is equal to the amount of rotations in our current Tetromino shape, so 4, we want to go back to the first item in our array. So in other words, the first rotation layout again. If this statement is false, we simply want to pass through that new current rotation number into our current Tetromino like this. and then we draw it. Okay, now let's not forget to uncomment this out here. We need to do this so that when we press the up key, the shape will rotate. Now let's refresh our page and see how that works. Okay, great. We are now ready to move on. In this lesson, we're going to be covering everything we've learnt before to essentially build a mini grid to the right of our grid right now. We will be doing this so that we can display the upcoming shapes for our user. This is a great lesson as it can also be considered a mini recap of all the work we have done so far. We will be going over how to create a grid, pick out elements to style in our style sheet, pick out elements to add functionality to, and how to work with arrays in order to pick our next shape. Okay, so let's get started. The first thing we're going to do is go over to our HTML and do the following. We are going to add a 4x4 grid to our game. So how do we do this? The same way as we did it before. We add 16 divs here and put them in a div we will choose to call our mini grid. Now let's flip over to our style sheet and similarly to the other grid, make our mini grid 80 by 80 pixels. I'm going to use Flexbox again and then wrap them over themselves like this. Okay, great. And there we have our mini grid. Now I want it to display to the right of my main grid, however. To do this, I'm simply going to put two grids, and the two grids only, into a div of its own that I'm going to choose to call container. Now, back in our style sheet, I'm going to use Flexbox again to make these two items display in line. I am also going to do one thing to make it look a little better, and that is add a margin left of 50 pixels. Okay, great. Now we can see that there are two separate grids next to one another. Now let's move on to our JavaScript code. So the first thing I'm going to do is pick out each div in our mini grid and call it display squares instead of squares. Once again, we do this using query selector all, as we want all the divs inside the div with the class name minigrid. Note, we are not using array from this time, just to show you a slightly different approach. The next thing we need to do is tell our JavaScript how big the width of our minigrid is. Let's use display width instead of width for naming this constant. We are also going to need to set our index at 0. Let's call this our display index, so our JavaScript knows we want to talk to the minigrid only. Now we need another array. We need an array of our 5 Tetrominos as their first rotations for our mini grid to show. We do not need all the rotations, as we just need to display our Tetromino here. As you can see, I am simply rewriting the L Tetromino's first rotation here, same for the Z, T Tetromino, and so on. Okay, now let's get to writing a function that will display our shape. Using the display squares I have collected, so all the divs in our mini grid, I am using forEach to get each item, or as I'm going to call it, square, and remove any trace of a Tetromino class from it. So that's for the whole mini grid. I'm removing the class Tetromino from the whole mini grid. Next, I'm going into the next.tetrominos array and using nextRandom. So let's define nextRandom as a value. I'm going to start with the value of 0. So nextRandom be 0. Let's actually move this up to the very top of our file. We are doing this as we also need to use it in the freeze function. So right before we choose a random Tetromino for our main grid, we are adding one more step. What is happening here, the value next random is being passed onto the random value. So we choose a next randomly selected Tetromino, assign this value to next random. This means we now have a value. Okay, let's get back to writing our display shape function. For each square that makes up our now randomly selected up next Tetromino, we want to add a class of Tetromino to it. We then want to pass it through our display squares. Hopefully this approach is now familiar to you. Let's see if that has now worked. Save your file, flip over to the browser, hit refresh. And great, that has now worked. Now, what would be really great is if we can get this shape to display as soon as our game starts. For this, we're going to start to hook up the start and pause button. This was quite a tough section, so I would recommend going slowly on this section and trying to console log each step as you code, just to make sure you understand what is happening under the hood. Feel free to go over this section once more if you need to. This lesson is going to be all about setting intervals and clearing intervals. This is an extension of what we touched on previously when we told our JavaScript that we want the moveDown function to invoke every 1000 milliseconds. We are now essentially going to move that function into an event listener that is attached to our button that we have an ID of start button for. This means that every time we press the start button, we are going to invoke the function moveDown with its set interval. We are also going to go a step further to see how timer IDs work by adding a pause functionality. The first thing we're going to do is grab our button we gave an ID of start button to that we called start button above and attach it to an event listener. It's saying not defined. Let's see why not. Okay, I used a capital here. I'm going to change this. I'm also going to change this for the score display. Okay, let's carry on. As you can see, everything's really case sensitive and spelling is really important when coding. I'm also going to let our timer ID be null by leaving it blank like this. Okay, so if the button is clicked and we have a timer ID value, so the value is not null, we want to pause the game. We do this by passing timer ID through clear interval like this and setting the value of our timer ID to null. Else, when the start button is pressed, we draw the Tetromino in what is the default current position, so 4, put the timer ID on a set interval of invoking the moveDown function every 1000 milliseconds, select the next random shape we want to display in our mini grid, and invoke the display shape function we wrote that will display the randomly selected Tetromino we just determined. Okay, great. We now need to uninvoke the moveDown function that is on a timer that we wrote previously from our code. So get rid of it unless it's in the start button event listener. So what is happening here is that because we have this line of code, the set interval that starts our Tetromino moving down is invoked on the load of the browser. We want it to be invoked only if we press the start button. So let's comment this out here. And let's refresh our browser. And perfect. Let's carry on. In this video, we're going to take a break to look into what exactly Splice is and does. Using Splice on an array can totally change its content. We can remove items from the array or remove them and replace them with totally new ones. It is important to note that it will change the original array once this particular JavaScript method is used. In other words, we are mutating the array. So, to recap, Splice can remove an item or items from any position in an array. Splice can also remove an item or items from any position in an array and replace them with new ones. Let's have a look at how this works by flipping over to our code. Okay, let's get an array we can work with. I'm going to call it planets. So we now have an array of 4 planets. Now, what if I want to remove Pluto from my array, as I'm not sure if it's a planet now anyways? I would use Splice to do this. Typing my planets array, I would attach Splice to it like this. Next, I would pass through the index of the item in my array I want to remove. As I only want to remove that one item, I'm going to pass in a 1. So 2, 1. Okay, great. Let's console log planet splice 2, 1 in brackets. You will see that we should get Pluto. If you console log planets, you will see that our original planets array now only contains 3 planets without Pluto. Okay, now what if I have changed my mind and want to re-add Pluto, but also add Uranus? We can use Splice to do this. Let's say I want to put in the first index of my array, but not remove anything, just put Pluto back, as well as add Uranus. I would do so like this. We pass through a 1 for the first index and a 0 as we don't want to remove anything, and then the 2 strings we want to add at index 1. Let's have a look at what this gives us. And perfect. As you can probably tell by now, the first 2 parameters are the start index and the delete count respectively. Leaving the delete count 0 will not remove anything from the array. You might have also noticed that we get a return of the removed items or item every time we use Splice. I have just one more example to show you before we move on to implementing this in our Tetris project. So, say I want to remove every single item from my array after Mars. That's right, and I believe that Mars is the only planet. We can do this by simply passing through the index number into Splice. Passing this through returns all of our other planets, and if we console log planets, we will now see it only consists of Mars. Okay, great. Now that we have covered Splice, let's move on to implementing it into Tetris. In this section, we're going to be focusing on what happens when the user manages to fill a whole row with Tetromino squares. We need to do a few things here. We need to remove the row from our grid, or array, add an increased score to our score tally, display the score on our browser, and add a new fresh row to our grid or array so that the grid doesn't appear to shrink in size. For this, we're going to be focusing on Splice, concat, and appendChild. As we now know, the Splice method adds and removes items to and from arrays and returns removed items. Let's move on to concat. Concat allows us to merge 2 arrays together. Let's use the same Tetrominos array. Now, let's say we want to add another array to it. We do so using concat. Here is my second array, and I'm going to call it shapes. By using this syntax and passing through the shapes array like this, we get the 2 arrays joined together. And finally, appendChild. AppendChild is an inbuilt JavaScript method that allows us to append elements to an existing element, for example, our grid. Let's have a look at how this works in an example. First, let's recreate a grid. So make a div with a class of grid. Now we're going to be appending divs into this div with a class of grid. So let's add some styling so we can actually see them. Now let's get the div with the class of grid using our query selector and call it grid for our JavaScript. Now using createElement, so that's another inbuilt method, let's create a div in our JavaScript. Now let's put this created div into our grid using appendChild like this. And ta-da! We have now put a little red square into our div with a class of grid. Now let's use these 3 inbuilt methods in our project. Let's get the lesson started by creating our addScore function where we want all the steps outlined to happen. The first thing we're going to do is write a for loop. This loop will loop over our entire grid and all its squares every 10 squares, so width by width. The for loop syntax in JavaScript looks a little bit like this. In this example, what we are doing here is 3 things. Setting a variable before the loop starts, so var equals 0. Defining the condition for the loop to run, so I must be less than 5. And incrementing the value by 1 using the increment operator, we move on to the next item in our array to loop over. So, what will this look like? Let's have a look with an example, an array that I have called shapes. Now, if we use the for loop to loop over the length of the array and loop over each item one by one, what will we get if we console log shapes? We will get a list of the shapes printed out in our console log. Okay, now let's use this in our project. We next define what we want our row to be. This will be the I, plus every square that makes up a row. Now we use an inbuilt method called every to check if every square in our defined row contains a div with a class of taken. If it does and the statement is true, we do a few things. We add 10 to the score. We display this to our user using the score display and an inbuilt method called innerHTML. And for each item in the row, we remove the class of taken. And we take out this row using Splice, like this. I have assigned this taken out row to a const called squares removed. Let's console log this to see what is happening. Okay, great. You can see here what our row is and what it's made up of. Now let's re-add these squares to our squares array so that the grid doesn't appear smaller. So what we're going to do is we're going to append these new squares to our grid. Let's go back to our browser, hit refresh, and great. You will see here that our row has cut itself out and appended itself to the beginning of our array. Okay, let's remove the class Tetromino, so the blue, so that it looks like it should. Amazing. We are now down to the final stage of our game, which is defining what a game over is. We are now nearly at the end of our Tetris course. By now, you would have covered all the following inbuilt JavaScript methods and used them in our project. This is pretty impressive. We only have one more thing left to do, and that is define what is our game over. Now, as you know, Tetris finishes when you stack up all your Tetrominos so that they don't fit in the grid anymore. This makes our writing of the game over definition super simple. All we have to do is tell our JavaScript that if there is a taken shape present in the original default position or index 4, we call it a game over. Okay, let's write our game over function. We're going to write a game over function. In it, we are going to have an if statement that says if some of our current Tetromino shape that is in play, if some of its items or indexes at the current Tetromino's current position contain the class of taken, we call it a game over. We then display this in our score display. We then also clear the game's timer IDs so that the auto move down function stops. And there we have it, a fully functioning game of Tetris. Now, I would love for you to take this game, make it your own, share it with me on YouTube. My channel is Anya Kubo, or on Twitter at Anya_Kubo. I would love to see what you have made and how you've taken this and made it your own and taken it to the next level. The options for you to do this are adding levels, adding a line count, maybe adding some music to the game, or just styling your game to the max. I do have one final lesson for you that I think might be quite interesting, that is to do with styling of the Tetromino colours. If you want to learn how to do this and also want to learn how to tidy up your code for best practice, please do watch my final video for this series. Hi and welcome to the last video in my JavaScript games tutorial. If you want to learn how to assign colours to each Tetromino and also want to learn how to tidy up your code for best practice, definitely watch this last video in the series. Once again, I hope you have enjoyed this series, and if you do have any questions, please do not hesitate to contact me on my socials below. Okay, so the last thing we want to do is assign colours to each of our Tetrominos. We will do this in our JavaScript file. First, we want to make a const called colors. In it, I'm going to put the colors I want my Tetrominos to be in the same order as they appear in my Tetrominos array. This means my L Tetromino will now be orange, my Z Tetromino will now be red, and so on. Now that we have that, we need to find each time we add and remove the class list of Tetromino in our code, so we can add this color on top of it, so after that line of code has been written. The first instance I can see this in is in the draw function. Let's use style and background color to add styling in our JavaScript file. We also pass through whatever value is currently random into our colors array. This means that if the random Tetromino is currently the L Tetromino, the color we will get back will be orange each time, as we are passing through a 0. To remove the color, as we need to do for undraw, we just leave an empty string like this. We also need to do this for the minigrid where it displays the next shape. Let's do the same, passing through next random instead of random. Finally, the only place to remove the color is here, in the add score function. Let's see if that has worked. And great. Now, just a quick cleanup. You can see here I'm getting rid of any additional lines, commented out code, and changing this as it should be a const, not a let. And there we have it. Thank you so much for watching my video.